Hi guys, no new content today, but what we're looking at is where we might use parametric equations. And when I first spoke to you about them, I spoke to you about separating the x movement and the y movement, because y is affected solely by acceleration due to gravity. Because weight acts down, there's no force in the horizontal plane. So by separating x and y, you can work much more easily. So I want to look at this example. It's on the screen. It says a stone is thrown from the top of a 25-metre high cliff with an initial speed of 5 metres per second and an angle of 45 degrees. Its position after t seconds can be described using the following parametric equations. So I'm just going to write these down. So x is equal to 5 root 2 t, 5 root 2 over 2 t, and y is equal to minus 4.9 t squared plus 5 root 2 over 2 t plus 25. And it says where x is the horizontal distance from the point of projection, so it's how far you've gone horizontally, and y is the vertical distance from the ground. And you'll notice that when time is 0, that y formula is just 25 because the first two bits have disappeared. So that adding 25 on the end is really what's telling us that it's starting 25 metres up in the air. And the time is between 0 and a constant k. Now our first question says, given that the model is valid from the time the stone is thrown to the time it hits the ground, find the value of k. Well, if it hits the ground, then y equals 0. It's got no vertical distance. So from that I can say that minus 4.9 t squared plus 5 root 2 over 2 t plus 25 equals 0. And I went straight to my calculator and went for menu A, and 2 for polynomial and 2 for quadratic. But I'm sure you're used to using that on your own. And I got 2 answers. So I got one answer for t was 2.648, and the other answer was minus, and I'll just try and read it here, 1.927. Well, this one here is a time in the past, so that's before we even started, so that's not valid at all. So this must mean that at time 2.648 seconds, this stone that was thrown hit the ground. So that would mean that k is equal to 2.648. And I would store that, going STO, and then pick one of these letters. So I'd put STOA, and that will store that in memory A. So that's the answer to question A. Right, part B says, find the horizontal distance travelled by the stone once it hits the floor. So we're looking back to the formula x equals 5 root 2 over 2 times time. Well, our time is 2.648, and putting that together I would get that it's travelled 9.36 metres to 3 significant figures. Now, so common in these types of questions is using something within the wording to find t at a particular point. So here we were looking when the stone hit the ground, that told us that y equals 0. Once we knew y equals equal to 0, we'd got this quadratic expression equal to 0. That made a quadratic equation. And then solving that using our menu A function on my calculator, or you could use minus b plus or minus the square root of b squared minus 4ac all over 2a. Either way, but I think because we're allowed to use technology, we might as well make the most of it. So using menu A on that, and then the simple thing to do after then was just substitute that value of t into x to tell us how far it would have travelled horizontally by the time it hit the ground. So separated x and y in the way it's travelling because of acceleration only accepting in the y. We'll come to that more when we do projectiles in mechanics, but for the moment, find t for one and substitute it into the other is a very, very common theme. Okay?